My name is Dr. Lizeka Samba. I'm a maths education lecturer at West University. I'm also with TUT, whereby I'm doing professional development for the lecturers. I've been with UNISA for quite some time. I've been a qualitative facilitator 5 years ago. So my expertise is on how we learn mathematics. That's my strength. So I think I'm the best person to help you to understand maths, because the reason why we find some of our modules that have got mathematics is because we don't know how to converse mathematically. That means we don't understand the mathematical discourse. What is it that you have to bring in mind when you are working with mathematical terms? And also, how can you think mathematically? And also, how can you reason? Because this is the language. So my aim is to help you to bring in that kind of discourse, that kind of thinking, because I can help you with some of the questions, how you can answer them. But when you get to the exam or assignment, they can be different. But my aim is to help you to say it does not matter which question can come through. How can you answer that question? So that is the my philosophy of doing these facilitations. So today we are doing a simple interest and discount. So the object of learning, what is it that you are supposed to learn about the simple interest is you need to master the basic concepts and the applications of simple interest and simple discount. That is the aim of this facilitation. I will bring in some little bit of compound interest, just basic. I'll bring in some little bit of compound interest, because you find that when you are answering the exam questions and the assignment, you do find those questions asked at the same time. So now I get what I call the critical aspects of this topic. What is critical about this is for you to understand. Make sure you are aware of the words. Remember, when you are learning any language, you need to know the kind of words. How are they different? Okay, you need to understand what is an interest. An interest, you can, yeah, I mean, we know it from everyday kind of language. It's something that is positive. It's something that is adding a value. Okay, that's an interest just from everyday language. It's got the same meaning in mathematics, but we are mathematizing it. And then you must compare that with a discount. A discount is when something is the value is decreased, so it's got a negative operation. So if you compare those two, we are going to be looking at those two, looking at the formulas, because I'll share with you the misconceptions. Okay, because when you're answering, especially the multiple choice questions, you find that you will get the answer correct. You think is correct, but you have chosen a wrong formula. So make sure you are aware of what different formulas that you need to be applying. Okay, and now you need to know what is the principal or the present value, the term, interest rate. Okay, so there's a simple interest and there's an interest rate. Those are two different things. Make sure, Guti, when you are answering the questions, you are able to read what the question is asking you to do. Is it asking you to calculate the simple interest, or is it asking you to calculate the interest rate? Okay, and then we've got the future value, we've got the maturity date, the timeline, the simple discount, and the discount rate. Okay, again, make sure you are aware what the question is asking you. Is it asking you for a discount rate, or is asking you for a simple discount? Okay, and now there's a nominal of face value, number of days, time value of money. Those are the keywords that you need to be aware of when you are working with with this topic. Other critical aspects are your own misconceptions. they become part of your learning. We are learning from what we know, our current knowledge. Sometimes our current knowledge is not because we don't know, it's because we are carrying some previous knowledge which had misconceptions and difficulties. So those are the things that I would like you to be aware of when we are doing any topic. Hence, I'm asking you, if ever you are studying any topic, please write what is it that you are expected to know about that topic, the object of learning, and what are the critical things about that topic at your level that you need to know. And then what are your critical aspects in relation to the misconceptions that you are carrying? You write those down so you'll be able to even ask for help. You can be able to even contact me and say, I've got problems with these ones. So other things that have been identified in research and that we are aware of is choosing the correct formula. So you need to make sure that you are using the correct formula. Another thing that can be problematic is substitution. Substituting the correct values in your formula, that is also a difficulty that we always come across when we're working with mathematical calculations. And also the calculations in general, they are problematic because some of us, remember, we have not done mathematics for a very longest time. It's easy that you could have forgotten the rules of the operations, that is multiplication, addition, division, and is it addition and subtraction, multiplication and division. So those are the things that we are going to try and make you remember, and also reading the context. Reading the context, it is problematic because now most of the questions that you come across, they are contextualized. So now how do you decontextualize the mathematics and put it in a mathematical form? So those are the difficulties that we always come across. And then other misconceptions will be the issue of time. For example, um um you could be using the incorrect percentages. Maybe you are told that the interest is compounding weekly, is compounding daily. Those are the little nyana issues that you could quickly you could have the difficulties of dealing with. So we'll be trying to highlight those. This is an example where you could find that there are misconceptions, whereby there's an investment of 7,600, which is invested in 2 years at 1% per month, simple interest. This is per month. It's not just yearly. So now it is important that you take into consideration those months. So what is the value of the investment after that time? The value of T is sometimes is written as 2 and not 24. So those are the misconceptions that you would find that as soon as you find that your time is 2 years, you don't even read the whole question. You just assume that your time is 2. However, it is important to look out for any compounding times whereby the interest is being paid. Okay, so I'll be highlighting these difficulties as we are going along. Okay, so this is simple interest. The learning outcomes under simple interest. We'll be looking at simple interest and discount and then do some exercises. So for simple interest, you need to be explaining the terms. What is an interest? What is a rate of interest? Those two needs to be differentiated. The principal and the present value, the term of the loan, especially if ever the term is changing. Maybe you invest at first year for 10 years, but somewhere down the line you change the interest rate. So that is very important that you understand what do we mean about the term of the loan, and then the sum accumulated and the future value. And then we have to take all of these aspects. We need to be able to take all of these aspects and calculate them. We are going to be applying them here and calculating them. Okay, so now the definition according to your notes is saying the interest is the price paid for the use of a borrowed money. But what if you are not a borrower, you are an investor? It's not correct that is only for borrowing the money. It's also when you invest, you put in some money in the bank. It does not only it does not only refer to borrowing, it's also referring to the it's referring to investment. Okay, and then if you Google, you Google just since you are studying alone, I mean, you always look for resources. You'll come across good, you've got formulas. This is a formula that you can find of a simple interest. And then this is this is just for simple interest. Okay, and then this is an accumulated. This formula has been derived from the simple interest, but it's for the accumulated amount. I'm going to be using the standard formula that is used on your notes because there are so many ways that are being used for the sum that is accumulated or the future value. So I've decided to stick to the format that is used on your notes so then you can follow the thinking. And then the interest rate for the simple interest, it is calculated per annum. Okay, the T must be in years when you are calculating. It must always be in years or a fraction. It can be a years or in fraction. So if the interest rate is expressed as a shorter period, maybe a month or a day or weeks, it needs to be expressed accordingly. That means if ever you are told that the interest is paid monthly, it means you have to divide that interest by 12. If ever is weekly, by 52. If ever is days, it is you divide by 365. Okay, maybe they say the interest it is paid weekly. That means you are going to divide the interest by 52. That is the number of weeks in a year. Okay, so um so the simple interest, just an interest, is going to be an amount. This is the formula. So these make sure you are aware of the formulas that you need to bring to memory when you are working with simple interest. So these are the basic formulas that you need to keep in mind when you are working with simple interest. And then the amount that is accumulated at the end of the period of investment. This will be the formula. That means the principal value together with your interest, the interest being this one. Okay. So this is one formula, and then another formula will be this one. Most of the time we are using this formula, but sometimes you don't necessarily have to use this formula. It depends what information that is given to you, but be aware of the formulas. So then after you have analyzed, you have done what I call a global approach, analyze the question, you know which formula to bring in and use. Okay, so for example, okay, you've got this question. This question is saying now you need to calculate the simple interest. Okay, you are asked to calculate a simple interest, then you know if you are asked to calculate a simple interest, you know which formulas to use. The simple interest formula, you know, it is I is equal to PRT from the previous slide. Okay, that's what you are asked to calculate. You are asked to calculate this. The sum accumulated, it is just equal to S. So your S is equal to this. It's borrowed for 90 days. Can you see now? This amount is not per annum, but it is but it is days. So now when you've got days, now your time here. So now the components of your formula, you need your present value, you need your interest rate, you also need your time. You read, you diagnose your question and break it down. So the time, it is 90 days. Remember we said if ever it is for shorter periods, if ever it's days, you are going to have 90 divided by 365 because you are working with days. When it's days, you divide the number of your days with your 365, and then your interest rate, you are told what your interest rate is 15%. 15%, it is 0.15. Mina, I always want to check. I do take the calculator to make sure that I've got a correct conversion of my percentage, because it's easy when you've got 7% to write 0.7. So you can just write 7 divided by 100 just to be sure you are really converting to a correct decimal number of an equivalent number of that percentage. So now you've got this, and then you are looking for your S. So now what is it that you are but it's calculated as impedance and the sum accumulated. Okay, now English it can it can really throw us off. Okay, it has thrown me off even now. It is saying calculate the simple interest and the sum accumulated for. Yeah, that is English. It's the sum accumulated for. So here you are supposed to calculate for the simple interest and the sum accumulated. So you are asked to calculate for I, and also you are asked to calculate for S. Okay, it is just to read the English, and then it is for what? It is for a specific amount. That means this is an amount that I have right now that I need to calculate this simple interest for. So now I have to calculate the sum accumulated for. That means this will be my present value. Okay, your 5,000 becomes your present value. Okay, so things that throw those us off, it is just breaking things down from the context into the mathematical form. So now that you've got all of your components, you plug everything into your calculator. So what you have here, you are going to have your interest here is equal to 5,000 multiplied by 0.15 multiplied by 90 over 365. I will not be able to work with my online calculator. It just gave me problems. I've tried to download it. So if you've got problems with using your calculator, I will definitely take you through. You can just contact me, then I'll take you through on how you can use a calculator to just get these, because some of the calculations can be very complicated. So here the answer that you would find, it is 184.93. That is your interest that you calculate. So remember, there's another formula. You've got this one that was asked. You already got this one. You need to calculate for the sum accumulated. The sum accumulated is equal to what is the sum accumulated? The sum accumulated, if this is your interest, let's check. No, you're only asked to find Yimilo Paisai. You are asked to find the sum accumulated. So the sum accumulated would be, where am I? I need to get my formulas. So the sum accumulated is equal to P. So this is your P plus I. That is your sum accumulated. So your sum accumulated will be your P plus I. This implies that your sum accumulated, what is your P? You already have your P. Your P is 5,000 plus your I is equal to 184.93. So you just plug this thing into your calculator, which is going to be 5184.93. And then omunye umuntu can come back and say, I mean, what if I did not see that, Mina? My thinking is to say, no, I'm going to use a formula. I'm going to use this formula. Let me get the different pen. Let me use green. Okay. What if I have decided to use a formula, S is equal to P into 1 RT. Okay, because remember that those are the formula that I've got access to. So is it a crime for me to use this formula? The answer is no, it is not a crime, but you are trying to be economical with your time. You cannot be using something that when you've got all of the information. But if you think this is going to be economical, you don't want to go through all of these steps. But the most important thing is for you to decontextualize the context. After you've decontextualized, you can get any formula that you like. So this is a formula that you can use. So this you can just substitute. Maybe this one is economical. We don't know. It depends on your appetite of wasting money or time. We don't know. This is going to be 0.15. Your time is 90 over 365. So maybe others can think this is economically. You just plug in this thing into your calculator and then it gives you your accumulated sum, which is 584.93. Okay, it does not matter which method you use, as long as you get the correct answer. This will depend on how economically you want to become. So what I was demonstrating is to say you've got all the formulas that I've discussed. You can use anyone as long as after you have decontextualized. This is your decontextualization of your scenario. This is the decontextualization of your scenario. Once you have decontextualized, you can use the formula that you think is going to be economical for you. But if ever you don't want to be economical, it is still up to you. So here, what is important, the highlight is to be able to read the English. It is remember I said, one of the misconceptions and difficulties that we always come across, it is when we cannot move from the word problems into mathematical space. So I was highlighting those, Guti. It is easy for one to think this it is the future value. So make sure you are able to just practice and understand how to decontextualize. That is the main thing of our learning with a simple interest. Okay, and then okay, here we are saying determine the present value of the loan of the maturity. Determine the present value of a loan. You are asked to find the present value. Okay, of a loan issued today with a maturity value, your future value. Remember, your future value is the same as your accumulated value. That is your S. Your S is equal to 12,000. Okay, in 2 years' time, your time here is 2. If the simplest interest or simple interest rate, you are told that the simple interest rate, so your rate here is equal to 0.12. I am not going to go through each and every calculation. I'm just highlighting things that I think we are struggling with. Okay, here you know what you're looking for P. So now you know go to your S is equal to P into 1 plus 1 plus RT. We are getting the correct formula because we are told we are working with simple interest. That's your keyword. The simple interest you are told, Guti, that's what you are working with, so you know which formula. So what you do is to substitute the correct value. Here, the misconception is when you would substitute P in the place of S. That will be the misconception. Make sure that you are aware of that. Okay, so I'm not going to be doing a substitution, guys, here. I just want to get you through, and I'm going to do calculations where I feel I need to be emphasizing some calculation errors. Okay, so here is another example. In this example, you are asked at what simple interest rate should Lala invest if she wants to grow 2002. This one I think is straightforward. You are at what simple interest rate you are asked to calculate. And it's a simple interest. You know good, you need to get a formula for simple interest because it is just telling. The question is straightforward. And then for Lala, if she wants to grow from, that means to grow, that is your principal value of 2.5. And then 2, that means is your S, which is equal to 4,000. And then your T here is equal to your T here your T here is equal to 5. This one is also straightforward. It does not have any periods that are less than 1 year. So it is easy. You just get your formula, which is P into 1 plus RT. So all of your components are here. Your I is the same as your R, guys. So you can substitute accordingly. Then you get your calculation. And then another thing that you have also to keep in mind, it is the timeline. The timeline is the best way of helping us to think. Okay, it's helping us to think as informal as things can be. You just draw your timeline to tell the story. When happened, what happened at which specific time? Did the interest rate change somewhere? So the timeline, this is a basic timeline. I'm going to show you an example of a timeline, how you can converse with a timeline. Here's an example of a timeline. Here is a story whereby you are told Guti when his son was 6 years old, Metuli made a deposit of 6,000 in the bank. The investment grew at a simple interest rate, and when Metuli's son was 18 years old, the value of the investment was that amount. That means this is an accumulated value. You can even write here and say this is your accumulated value, and then this one is your principal value, and then there's a time that you are given at what rate was the money invested. So here you are asked for an interest rate or R, and then give your answer in correct lento. You just want to get the time, so the timeline is going to help you here. So here is your timeline. This father Umetuli, the son is 6 years old. That means at time 1, okay, the son is 6 years old, okay, and then this thing accumulates, and then he deposits your present value. You deposit is 6,000 6,610, and then when the time 18, okay, when time 18 when time 18 when 18 years, that is, I'm saying, let me say this is T2, that is the end time, that is 18 years. So you are looking for interest rate on this time. So what are the components of your simple interest? The simple interest formula is saying you've got P into 1 plus RT. Do you have all of the components for you to be able to calculate what you are asked? You are asked to find OI. So now let us break down our components. You know what is your P. Your P is 6,610. You know what is your S. Your S is equal to 11,131.24. And you don't know what is your R. That's what you are asked to find. Do you know your T? Okay, because now we need to see whether are we supposed to calculate using simultaneous equations, or we are supposed to use just single equations. But we are given time. It is implicitly given. The sun is 18. There's a month that is accumulated, and the sun was 8 when this thing started. So now, how many years was this thing invested? So it is 18 minus 6. Okay, 18 minus 6, that is going to give us 12. So your T is 12. So some of the information is implicitly given. It's not that you are given 2 times. You just need to be able to understand the story. Okay, what is the story? So now the timeline helps you to be able to pick up the story on the timeline. So now you've got all of the components, and then you'll be having only one unknown. So now you can go and take all of these information, and then substitute here, and then you're only you're going to be stuck with only one thing that you are asked for, that is your R. Okay, so now I'm trying to bring to you what kind of ways of reading the story. I'm going to have more exam related questions on this after I've discussed the a simple discount. Then we can see how you can play around with these in the context of exam questions. Okay, so now we've got a simple discount. A simple discount, when you read on your notes, a simple discount, you need to be able to explain what is a discount and what is a discount rate. A discount will be the value amount. A discount rate will be the actual rate that you are given. And then in the context of a simple discount, the discounted value is what we mean as your present value. Understand? So it discounted value. So these are the keywords that will enable you to be able to decontextualize a story. So whatever is the discounted value, that will be your present value. That means your P in your formula. And then your face value will be your future value. Your future value will be your S, if you look at it in terms of when you are thinking of a simple interest. And then you've got also the term. We need to be able to interpret the formula and then translate it into timelines. And then the definition of this is the interest calculated on the face value. That means the future value of a term and paid at the beginning of the term. That is called the discount. Okay, why this is important? And it is important when you put a discount with a simple interest, with interest. Okay, so this can be used as the formulas that you are working with. Okay, so the first line, this is just for this is the definition, and then this is the definition. Now let's come to the formulas and contrast them against each other. Okay, so now in the simple discount, your discount is this formula. In the simple interest, this is how the equivalent formula for interest would be looking like this. So you need to see these things opposite each other. Okay, so now your simple discount, that is the amount. When you look at it from the simple interest side, this is how the notation of the simple interest. Okay, so now your P is equal to S minus D. Remember, we said your P will be your present value, which is going to be the S minus D. And then if you compare it against your simple interest formula, this will be the formula. Okay, so again here, with discount rate, this is the notation. With interest rate, this will be the notation. With sum accumulated on all of these notations, compare it against the simple interest, this will be the formulas. The T is the same, is in years. The time does not change, it's in years. So if ever your time is in days, you will divide it by 365. If it's in weeks, it's 52. So it is no different whether it's a discount or an interest. The time is not affected by the two scenarios. So the formula for a simple discount is looking like this. If you compare it against the simple interest formula, this is how it's going to look like. So it is important to see these two. So then when you have to calculate the equivalent interest rate, you know how do they work. Ngoba it is easy for one to use this formula when they are asked for a discount. Okay, why am I saying that? It's easy to say your simple discount is S is equal to P into 1 minus RT or DT. Okay, can you see, Guti? These formulas are not the same. Okay, this is an incorrect, it's a misconception because we are so used to simple interest. It is easy for us to think simple interest and apply it with discount. Kanti, the discount, simple discount formula is different. So make sure you are aware of these differences. This is one of the critical aspects that I want to emphasize, Guti. It is not that we don't know these things, it's because we make those little nyana misconceptions. We all have them. Okay, some are errors, some are just a misconception. Okay, so here are the formulas. Sometimes it can be written like this, sometimes it can be written like this, but I am suggesting that we need to stick into this one because that's what your notes are suggesting. So it will be sticking to this format. Okay, I have just brought in these so then you can see what we mean when we talk about future value and the present value and so on and so on. Otherwise, we are going to be sticking to this formula. Okay, and then you find that when you are working with simple interest together with a simple discount, there is what you'd find that is called an equivalent rate. Okay, so an equivalent rate is when an equivalent rate is when you are told that equivalent is when the two rates are equivalent for the same present value, they yield the same maturity value at the end of the term. Okay, so now this is the formula for the interest rate. Okay, in our context, this will be our S. I just want us to stick to the same notation. This will be our S. Okay, so now if ever you've got a simple discount and then you've got you've got the simple interest, these are the two formulas that you would have. Okay, so now these two, your S can be equal to your S. If ever your S is equal to your S, you are going to have an equivalent rate. So this will be the formula for an equivalent interest rate against the discount. This will be your formula for the discount rate against your interest rate. So when you get a question asking you about the equivalent rates, these are the formulas that you must use. Okay? So having said that, here is an example. Okay? This example is saying determine the simple discount on a loan of 3,000 due in 8 months. So this determine a simple discount on a loan. A simple discount, it is your capital D. Okay, you are not asked to find a discount rate, but you are asked to find a discount, a simple discount on a loan. The loan is equal to, remember, um, a simple discount is calculated on a future value. Okay, that is the definition of a simple discount. It is calculated on a future value. So here, the discount of a loan, that means this is going to be your future value. Your future value, remember, has got a notation of S. So this is going to be equal to your 3,000. Okay, this is due in 8 months. So your T is equal to 8 months. If ever you are working with months, you divide those months because these are the months. You have to divide that by 12 months because this is shorter period than a year. Okay, so now your discount rate, the discount rate is a smaller nyana, D is equal to 0.15. Okay, what is the discounted value of the loan? Okay, that's what you are asked to calculate. What is a discounted value? Remember, a discounted value is your present value. You understand? Into when you are working with discount, the discounted value, it's your present value. But it is discounted. Okay, so this is another word. When you see a word discounted value, that means you that is your P. Okay, that is your P. Okay, so now what is an equivalent simple interest rate? And then you are asked two things here. Be able to dissect everything, break things down into smaller nyana pieces. Once you've got that, you get your formulas. Go to your formula box. See which one is going to be working for me right now. You are asked, you need to find your D. Awuyazi i-D yakho, awuyazi i-P yakho, you don't know your R. Okay? But you know from your formula sheet, you know your capital D is equal to your SDT. That is from your formula sheet. It is given. Okay, so now you said, okay, fine. I can easily get this one from this formula. What is my S? My S is 3000. What is my D? My D is 0, 15. What is my T? I know what my T is 8/12. Okay, what is important here, the things that I'm highlighting here are the misconceptions that we carry from reading the context. That is one thing that is always problematic for us. Be able to decontextualize this thing, break it down into smaller nyana pieces. After you've got all of the components into smaller nyana pieces, what is it that you're asked to do? Then you substitute everything. So here you can easily get your D, plug everything into your calculator. Your D is equal to 300. So now you've got your D. Your D is equal to 300. What else do you need to calculate? You need to calculate your P. Go to your formula sheet and check can I calculate my P from the formulas that are here? Yes, there is another formula which is saying my P is equal to my S minus D. Okay, I don't know my P, but I know my S, and I've just calculated my D. Okay, this implies that this is 2,700. Okay, now I've got my P is 2,700. Essentially only one thing. Okay, I've got only one thing that I have to worry about. So I am asked to calculate for an equivalent interest rate. So now that I know what I can calculate for simple, now I am moving out of the discount. Ne? I'm moving out of the discount discourse. I am getting into a simple interest discourse. The simple interest discourse is saying, if I want to talk about simple interest, I can bring in this formula. Okay, 1 plus RT. Okay, so now what is my S here? I'm taking this in because this is for the same information. I know what my S is equal to 3,000, and then my P, I've just calculated my P to be 2,700, and then 1 plus, I don't know my R, but I know my T. Remember, this is for the same information. I have not gone out of any of the context. It's just that I'm using different discourses to get my answers. That means I'm using a discourse of a discount, and I'm also using a discourse of simple interest. So my T, it is 8/12. So I'm going to have 8/12. So this makes my life simple, so I can deal with my mathematics. Plug in this thing into your calculator, and then you will get your R to be 16. I'm not going through e-calculation. If ever we are struggling on a calculator, please let me know so then I can help you on how to work with your calculator. Otherwise, from here, it's easy to simplify this. My aim on this question was, first, the misconception of decontextualization. Number 2, what are the different formulas that I have to use? Okay, you're just trying to make some decisions here. Then you can get all of the answers step by step. Okay, here's another example. This example, without going through, because I'm not going to have enough time to finish what I want to finish, but just quickly, a loan of 4,000 must be paid in 6 months time. In 6 months time. So my loan is a loan. It's a loan that must be paid in 6 months time. So now this becomes my P. Okay. My P is equal to 4,000. I'm decontextualizing, must be paid in 6 months' time. So my time is equal to 6 over 12. Okay. Determine the amount of money that you will receive now if the simple discount is am I correct, guys, for saying that my a loan of 4,000 must be paid in 6 months? Okay, here's one thing. I hope you are following on how we develop our misconceptions. If you are going to read and decontextualize line by line, you can miss the whole story. Okay, so Mina, I started to say a loan of 4,000 must be paid in 6 months. I said my P is 4,000 without reading the whole story. So I can miss out some information and decontextualize incorrect information, because this thing is saying a loan of 4,000 must be paid in 6 months' time. I'm already saying it's P, but there's a story that I need to finish. Determine the amount of money that you will receive now. Okay, you need to get the amount of money now if the simple discount rate of 18% amount is applicable. Okay, so here you have to find Ilento. You have to find your this, remember, this 4,000 becomes your S, not your P. You need to find your P first, and then your D is equal to 0.18. But then you don't know, you're asked to find your P, and then you also have to find your interest rate. Okay, so now here, the questions that you have to ask yourself, Guti, what are the formulas that I need to use? So the first thing, because I'm working with 2 discourses, I'm going to start with the discourse of the discount. So the discourse of my discount will be, I'm going to get the formula. D is equal to S dt. Okay, so I'm going to get my SDT, and then I can find my discount and then find my present value. This is similar as the previous question. So I'm not going to take you through this because there's a lot that I want to share with you, especially the exam equivalent questions. They are the ones that I think there's so much that is hidden there. Okay, so this is a question of determining the equivalent. Okay, we are looking for the equivalent discount rate. Remember, I said when you are asked to find an equivalent discount rate, the formula is your R is equal to D over 1 minus DT. Okay, so now once you've got this, you are given your discount rate is equal to 0.12, and then you are given your time. Your time is equal to 3 over 12. That's the first one. So you've got everything. So what you do, you take these things and then you substitute here, and then you get your equivalent interest rate. Okay, similar with 12%. I am not going to go through the calculation, but what I want to highlight, how do you read the keywords on your questions? Okay. Now let us start with one of our equivalent questions. Okay, this one, let's see if this is coming from one of the previous exam questions. This thing, you are told Gutinola invest 15,000 in an account earning this simple interest. You are just told it's simple interest. The balance in the account 6 months later will be equal to what? What I'm going to be doing here is to be decontextualizing the information. Nola invest in an account. That's what she is doing right now. So Nola invest this amount. Okay. This is a simple interest formula. I know because I am told. So a simple interest of 0.0657. Again, make sure you substitute. I always make mistakes. That's why I'm emphasizing things that I know are common misconceptions. It's not that you don't know. You always oversee these things. And then the answers on your multiple choice, they know what you'll be doing that misconception. So they get you there, and then you think you got the correct answer. The balance, you're asked to calculate the balance in the account 6 months later. So now T is equal to 16 months. That means you've got months. This is 16 divided by 12, because now remember we are working with 12, okay, to make it an annual figure. It must be a fraction because it's given in months, okay, because remember we said the time is per annum. So now if the time is given in months, it needs to be divided by number of months. And then what else? You are asked to find what? You are asked to find your S. I am not going to take you through the thing, but I'm just going to give a formula for the simple interest, which is P1 plus RT. So the reason why I'm not going to be spending time here is because I did not see any difficulties other than understanding how you convert the maths. Okay, that's the only thing. So you've got everything here. You go and substitute your formula, then you can get your answer, and then your answer there will be equal to this one after you've calculated everything. Okay, and then here's another question. A bank discount rate. You already know what you are working in a discourse of discourse. Go and open up a box of the formulas of your discount at the back of your mind. So now the discount rate is equal to 0.12. You need to pay the bank 5,000 in 6 months time. So now you need to pay bank that is what you need to pay in 6 months time. That is your future amount that you need to pay bank. That one, I think, is self-explanatory. In 6 months' time, so your 6 months' time, it is 6. These are the months. You just divided by 12. Okay. The amount of money that you will now receive. Now, remember the now will be your present value, which is equal to your P. That's what you are asked. So now this is your discount formula. You know it's your discount formula because you see good they are telling you, they are talking about the discount rate. So you know your here is the thing. I'm already starting writing about S when I'm working with discount formula. So the discount formula is equal to the discount formula is saying P is equal to S into 1 minus DT. I hope I did not make any error like this previous. No, I was using that one of DRT. Okay. So okay, guys, we are in a discourse of the discount. Your mind need to be clear. Don't bring in this is not, it's a misconception. If you are going to bring in a formula which is saying S is equal to P into 1 minus DT. Okay, this is an incorrect formula for a discount, guys. It's because we are so used with simple interest. It's easy. It's very easy to write a formula like this. Okay. No, you are within the discourse of discount rate. What is the formula there? Bring in a correct formula. Because if you are going to be using this formula, you will definitely get an answer, which is one of these. Then you will think you got it right. Okay, because remember the questions are designed in such a way that they are taking into consideration our misconceptions. They know what is easy for us to slip into this. It's easy because we are so used to work with simple interest. So make sure what you are bringing in the correct formula. Okay, so once you have brought in this correct formula, you can substitute everything and find your P. That is what I want to highlight here, is the misconceptions that we all carry. I am saying this because I also did the same thing. It's easy to slip to use this one. Okay, so that is very important. Okay, let's you look at this one. They say Frieda borrows 7,500 from the bank at an interest rate of 26% per year, compounded weekly. The amount that Frieda will have to pay the bank back after 78 weeks will equal to Freda borrows the money. That's what she's doing, borrows the money now. So now your P is equal to 7,500. Okay. At the bank interest rate, the interest rate here is equal to 0.26. Here, guys, can you see imagine? I've mixed the questions. I've even put in as a compound interest. So then I want you to see to contrast these things. So then you can be able to see a discourse, an interest rate discourse, and then a compound interest discourse at once. So then you can know which formula to bring in. So here we are saying now this is compounding weekly. You already know you are in a space of compound interest, and then you open up a box of the formula. Put the compound interest formula. This is the one that you want to use. It's the one which is talking about compounding. It's nice to use this one because whether it's compounding once or not compounding, it is fine because it will always help you. It will always help you to you don't use many formulas. So for compound interest, this is the formula that we are using. Okay, so now here you are told that this thing is compounding weekly. Something that is compounding weekly, that means it is 52 weeks. Your compounding, your M is for your compounding periods. So your compounding periods is M, that is 52. And then the amount that Freda will have to pay, you have to look for OS. You don't know OS. And then after 78 weeks. Okay. So now your time here is equal to 78. Okay, in this case, our our time has already here. This thing has already been put into weekly in weekly terms. So you don't need to be multiplying this t. This is MT. It is already in weeks. You've got weeks here. So it's only the I that needs to be taken care of. Okay, I will show you when you need to convert. If ever you've got the years here, if ever it was 7 years, but your interest is compounding in so many periods, you also need to multiply your years with that compounding amounts. But here is already been given to us. Our MT is already been given to us is 17 weeks. So you don't need to take that 78 and multiply it by 52. It's already been done for us. Okay, so here what you do, you're going to have your S is equal to 7,500 into 1 plus your interest is 0.26. Compounding so many times, you are going to divide by 52 weeks because our MT is already been given. The time is already given in weeks. So you don't need to be converting. So your MT, it is equal to 78. You plug this thing into your calculator and then you are going to get an answer of, what was your answer here, by the way? Of 11,066,60. So that becomes your answer. Okay, so here what I wanted to highlight is that your time has already been put into compounding periods. So you don't need to be redoing it. As you'll see with our other questions, whereby we convert the years into compounding periods. Here it's already been done for us. Okay, let's decontextualize the question. An investment of 20,000 accumulated to, and this one is self-explanatory. This is your P, this is your S. Without even reading the full thing, it's straightforward. If the applicable interest rate, simple interest rate, you already know at the back of your mind, oh, I am working with simple interest discount. So now your R here is equal to 0.12. Then the time under consideration is here. You are asked for a time. Bring in your simple interest formula. So your S is equal to P into 1 plus RT. So now your S is 45, 200, which is equal to 20,000 into 1 plus, what is your R? Your R is 0.12. Awuyazi ithi yakho. So I'm not going to calculate this, guys, because we were able to decontextualize this thing and put it into smaller yana components. We knew which formula to bring. Then you plug in everything, and then you are going to get that your T is equal to 10.5. That will be your the number of your the time period, the number of years. Okay. Here is another one. Okay. Here is this lady, Miriam. Miriam bought a painting for 15,000. Okay. I want to read the whole story before breaking it down. So now she's got this painting. For 10 years, the value of the painting increased yearly by 20%. That's another information that is critical. These are the critical aspects of this question. Thereafter, the value increased yearly by 15%. Okay. The amount of money that Miriam can expect to receive if she sells the painting after owning it for 23 years equals to. Okay. So now what is important is, what is this discourse that I need to be playing in? I don't see anything talking about simple interest here. I don't see anything talking about discount. How do I know? Because I know the definition of compound interest. Compound interest, it is saying the interest is increasing yearly. That is giving me increased yearly by, so every year there's an interest rate that is increasing, that is telling me about compounding. I already know what I mean, that I'm in the space of discount. Even on the second thereafter, this thing is increasing yearly. So I know into what, oh, I am working with compound interest. So I already know which formula I'm going to be using because of these keywords. But now there's there's something that is happening in between. Let me get the timeline. So then I can see what is happening. So if I want to get a timeline, let me get this timeline. Okay. So in my timeline, I've got my first present value. The first present value when Miriam was buying this thing was 15,000. Okay. This is 15,000. And then this is the time when she's starting. No, for 10 years. Okay, for 10 years this thing runs. When it comes here, okay, for 10 years, here my first one, for 10 years, this is my N1, which is my T. Okay, this is my T1 or N1. So for 10 years this thing is running. So now between this period when she started, this thing is 0.20. So I know what my interest rate here is 0.20. So that's what I'm told during this time. That's what was happening here. So painting was worth this thing, and then there is this year here. Okay, the value of the painting increased, and then obviously it increases. Here there's going to be an accumulated value, which angiyazi. I don't know the accumulated value for the first 10 years. Okay, and now after that the interest rate changed. Okay, the interest rate changed for remember this whole period is running for 23 years. This is 23 years. Okay. So now the painting, she has owned it for 10 years. She still has got another 13 years, so then to fill up 23 years. So now there is this period that is my N2. My N2 is equal to 13. 13 plus 10 for the whole period. From here, this is N0. This is N0. Okay, this is your N0. That's when you are starting. This is your term 1. So now these are all 23 years. Okay. So now you need to know what is going to be an accumulated value here at the end of this period. But now the interest rate has changed. So the interest rate here, you've got your first interest rate, and then you've got your second interest rate, which is equal to 0.15. Okay. Remember, here at S1, this is your first accumulated value. So at N10, your accumulated value becomes your new present value for this period. Okay, your S1 is the same as your new P1. Okay, that means the present value for this 10 year for this next 13 years. So I've got everything in my timeline. So I need to be doing 2 calculations according to my timeline. I have put down the story. I have decontextualized the story and put it into a timeline. The minute there's too much happening in a story, a timeline always helps. So then you can know what happened when, at which point things changed, and what do I do at a specific point. So now here you need to be calculating. You don't know what is your S1. If I know my S1, I will know what is my P2. No, this is my P2. I already have my P1. My P2 will be the present value for this period. Okay, so I've got 2 scenarios here. Let me start with the first one. The first one is going to help me to get the accumulated value for the first 10 years. The accumulated value is going to become the present value for the new period. Let me start with the first present value. Let me get the formula. The formula is going to be equal to S1 is equal to P1 into 1 plus I1 to the power N1. Remember, I said we are working with compound interest because this thing is telling me increased yearly. That's a definition of a compound interest. I know this is a compound interest because this thing is compounding every year. Okay. So now my S1 is equal to, what is my P1? It is given. It is 15,000 into 1 plus, what is my I1? My I1 is 0.20. There's nothing that is compounding quarterly or whatever. It is annually, so I don't need to worry about the compounding periods. So now my N here, my N1, I've got it from my timeline. My N1 is equal to 10. I can plug in this thing into my calculator, and then it's going to give me, this is going to give me 92876.05. This is my my S1. Remember, we said my S1 is equal to my P2. This at the same time becomes my new present value. So I am done here for the first period. Things change. So now I'm going to start calculating for the next 13 years. So starting here, being my referencing point. So now for this new period, let me get a different pen. For this new period, I'm going to be saying now my S2, I'm using a compound interest formula. My S2 is equal to P2, okay, into 1 plus I2 to the power N2. I'm just taking everything from my timeline. So my S2, I don't know. Your S2 will be an accumulated amount at the end of N13. Okay, so now this is going to be the actual amount of the painting on that year. That is on year 23. But I'm saying N2 is 13 because I want to calculate for these years. I'm taking whatever was accumulated here. I am calculating it for this period. Whatever accumulated value, that is going to be the value of your painting, of Miriam's painting. Okay, so now my P2, I've already calculated my P2. My P2 is 92876.05 into 1. My I2, remember for this period, my I2 is equal to 0.15. Okay, and then my N2, I've already got my N2. My N2 is 13. Voila, I've got everything. I plug in this thing into my calculator and then I get my answer to be 571. Woo! It's 571, okay? 446.59, okay? This is going to be the amount of e-painting, Miriam, on year 23. Okay, I was able to do that by breaking down all the story into a timeline. Let us see another question. I won't be able to finish all of the questions. I'll probably finish them next time because I want to share with you the way of thinking so then you can apply it in other scenarios other than simple interest. Okay.
Just a quick one, Lizega.
Yeah, Bo.
So there's no need of adding S1 and the final answer on when you're calculating S2 or P2.
You don't need to remember when you were here, Angit, when you are here, S1 has already been taken into consideration because your S1 becomes the value that was accumulated.
Yes.
You understand? If ever you are going to be taking into consideration your final answer and say S1 my S2, you are getting into what we call a circular argument because your S1 has already been taken into consideration because your S1 is your value of your P2. So now when you are calculating for your P2, your S1 is already being
taken
into consideration.
I get it.
Yeah.
I get it.
So that's why timeline is important. Okay, what is the story being told here? When I'm at this point, I'm working with compound interest. In compound interest, it is being calculated on an amount. Okay, so now you take that amount. It's like, let's say you are doing stokvel at Tinabantu. If ever we stokvel during the first year, they say you are paying 100 rand. At the end of that year, that you are paying 10%. So it has accumulated to 10%. So now your new interest rate is going to be calculated on the 110 for the second year. Whatever amount that has been accumulated, it is taken into consideration for the new period. That's why it's called a compounding interest. So your S1, we have already said it, which is P2, so it's already been taken into consideration. You don't need to add N1 and S2. S1 and S2, you are going to be getting into what we call a circular argument. And inflating imali, then you are going to be, if you are working at the bank, you fraudster. You are being fraudulent because your calculator isn't ngendlela engekho right, ne?
Okay, no.
Sharp. Okay. All right. Let's read the story, ne? Nangu this ululu. Guys, it's not that I like to be using abo amagama amantombazana. I just use any name that is short. Lulu deposit. No, it's not me. This was not designed by me. I took it from somewhere. Lulu deposit 900 into a savings account, earning 6.5 interest per year, compounding quarterly. Already, you are in a discourse of compound interest. So you already know what kind of a formula that you are going to bring in to help you. Yeah? Put it at the back of your mind. After 3.5 years, she withdraws money from the account and deposits it into another account, paying 11%. interest per year compounded annual. How much is the total amount accrued from both accounts 2 years after making the second deposit? Sure, there are things happening here. Okay. There are 2 accounts here. Okay. We are having this. I'm going to have a timeline here. Okay. Lulu deposits into an account. This is your present value. Okay. Your present value here. So there are 2 accounts. I'm going to read the one for the first account. Your present value. Your present value, which is your P1, is equal to your 900. Okay, so now here is the present for 6 and quarterly. After 3 years, that means this thing, after 3 years, you've got your N1, your N1, I want to write it there, is equal to 3.5 years. It is 3,5. Okay. So here, obviously, you are going to have your S1, okay, which you don't know, okay? However, during this time, Ululu decide to withdraw from whatever amount. During this time, she decide to have another account, okay? She decided to have another account, a second account, which I'm going to call whatever. So she withdraws 1,000. So now the I'm going to call it P2, which is for the second account, because now this is going to be 1,000. I've got 2 accounts. At the top is the first account, at the bottom is for the second account. Withdrawer P2, and then where does it withdraw? So when she withdraws, whatever amount that is going to be left here, she is going to have a new on the new account, on the old account, she is going to have here is what's going to happen here. Here's a story. I'm trying to write this story so then it can be believable. So now here, she is going to have this amount, okay? This amount, which is going to be starting here, which is going to be your I'm putting it as P1 star, okay? So it's going to be S1 minus 1,000. Okay. What is happening here on the old account? She's going to accumulate imali. Okay. So now a percentage yakho lana is going to be 0. This is 0,065. This is your N1. Okay. This is your N1, and then this is accumulating. This is accumulating quarterly, so your M is equal to 4. Remember, when something is accumulating quarterly, it's going to be M is equal to M4. So this is what is happening on the old account. But now at this period, she's going to withdraw you're going to have an accumulated amount, and then you take this 1,000, you're going to get into a second account, the one at the bottom. So this one is going to run its course. Okay, it's going to run its course, this, and then it's going to have an accumulated amount, and then it is going to be running for 2 years. Okay, same applies here. From here to here, your T is going to be equal to 2, the top amount, which is you want to know what is going to be your S. I want to call it something, S1 star. I think I'm running short of annotation. Okay, you don't even know this one. You don't even know this one. Okay. So now this is for the second account. This is for the first account. So now my advice will be, let's first deal with the first account. Let's see what is happening with first account, and then come with second account. So now with first account, what's the time? Okay. We are going to start with our first account, because now we are asked to calculate the total amount accrued on both accounts. So the first account, let's see how much was accrued. Yeah. Okay. If first account, it is compounding. We know what we are in a discourse of compound interest. So our simple interest formula is your compound interest. I'm sorry, guys. Your simple interest formula is going to be equal to P into 1 plus. Remember, once you see izinto that are compounding so many times, use this formula. Use this formula, it will never disappoint you. Okay, so you use this formula, you want to get your S1. Okay, I'm going to say my S1 is equal to, what is your P1? Your P1 is 900 into 1 plus, what is my I? My I is 0,065, and this thing is compounding. My M is for the compounding periods. Is compounding quarterly, okay? My first account. And then what is my M? My M is for 4, so I've got 4 multiplied by how many periods? What is the T? T here on top. T here is here. Let me write it. It's my T1. It is 3,5. Okay. So that is your S1. You take this thing and plug it into your calculator. So your S1, it is going to be equal to 11,11,27. Okay. I'm going to put everything into second decimal place. Or you can even leave it to 3 decimal place, so then you can be as accurate as possible. I prefer 3 decimal place. I know good money is not in 3 decimal place, but while I'm still calculating, it is best to leave things in 3 decimal place, and then you can put it into second decimal place when you get the final answers, just for accuracy. Okay, so now I'm going to put this thing into 2 decimal place, which is going to be 3 decimal place. I know money is not in 3 decimal place, guys. Ne? I'm being mathematically here. Ne? So now this is your S1. Remember, we said here your S1 is for a new for the first account. This amount is going to be reduced. Ngoba remember, kuthiwa uLulu withdraws 1,000 from this original account. So when she withdraws this, I am going to have a new amount. Okay, a new amount, which is going to be my P1, my P1 star. Okay, my P1 star, that means it's going to be in the new present value. If ever you can compare it with the previous exercise, your new P1 star is going to be equal to 1127,847 minus, she's going to withdraw this money. So now the account is going to be left with 127,85. Let's just put it to the second decimal place. It's okay now. Okay, so now this is going, I'm still working with my first account. I am not in my second account yet. Okay, so now I need to calculate the for the rest of the term. That means for 2 years, for the next 2 years. Okay, so for the next 2 years, I'm going to have my S1 first account. Okay, second, I'm putting it as a star, second account, which is going to be equal to your P is 127,85 into 1 plus the interest rate. Remember, the first account, it is still running on the same original rate. The rate has not changed. The rate, it is still 0,065. It is still compounding 4 times quarterly, and then for how many years? For 2 years, because the money was withdrawn. It still has to run for 2 years. So now this thing is going to be 2. Remember, this thing is compounding. Le first account is compounding quarterly interest corner. So I'm going to multiply by 4 because I want to get here. I want to get this value. I'm still on my first account. Okay, so now I calculate and get Guti, my first account there is going to give me a value of 145.44. That is this value. Okay. Look here, the same question that was asked. I'm sorry I did not get your name, Guti. Don't you, aren't you going to add this big? I mean, this thing is accumulating itself, it's compounding. The amount that was here was taken into consideration for the rest of the period. I don't need to go back and add anything. I am done with whatever that has happened previously. Whatever I'm going to be getting here, that is going to be my accumulated amount. Remember, uLulu uye wathatha imali yakhe. Uthathe 1,000. I accumulated this money, 1,127, and then after 3.5 years, she took 1,000. I was only left with 1,127. So I need to get interest rate for the 2 years, okay, with the new value, present value. So I'm getting 145. So that's what I'm going to get at the end of the period for this account. She started with 900, but she somewhere down the line, that's what we do anyway. If Mina, I go and invest money in the bank, I'll take my money somewhere because I've got a problem. So that money that is left in the bank is going to be calculated using the original amounts, but for the rest of the period. So now I am done with the account one. This is an accumulated amount. I leave it there. I need to go and calculate for the second account. Okay, I'm not going to get I'm not going to get a new slide, guys. I'm going to be working here, but I'm going to be using a different pen. Now I need to be working with the second, I'm going to say a second account. A second account. So a second account, this lady takes 1,000, maybe goes to Capitec and open another account and deposit 1,000 on different conditions. That is the information that is here. Okay, but it is still compounding interest because I am told, Guti, it is compounding semi-annually. So here, the M here, this is, I'm going to say this is my M1. The M for this the second account, M2 corner, it is compounding semi-annually. So there are different ways that that's other one, maybe it was net bank. So now I am after she took 1,000 and opened an account with Capitec. There are different conditions. I need to calculate what is happening there. So now on this account, I am told is compounding semi-annually. I'm using the same formula. This is the same formula because it's a standard formula. I'm just going to calculate because I'm looking for the accumulated amount of the second account. I'll give it that notation. So this is equal to, what is the present value of this account as a Capitec? It is the 1,000. It's a new account. So she opens a new account near 1,000. Okay. 1 plus the interest rate as a Capitec. A Capitec, they are charging her 11%. So your I second is equal to 0.11. So Bam charge 11%, but you are told that it is compounding semi-annually. When something is compounding semi-annually, we know we are going to divide by 2. So you're going to divide by 2. Remember, the formula is saying at your exponent MT. What is your compounding periods? It is 2 multiplied by how many years this account is going to run. Let's say Capitec for 2 years. That is your MT. So I plug in everything. This implies that when I plug everything into my calculator, I am going to get the value of 1. I'm going to get the value of 1, 2, 3, 8, 8, 2, 5. I am leaving it square decimal place. So this is your S2. So now Capitec is giving her 1,200. Ne? Capitec imnikeza lena. Inet bank, this is an accumulated amount. So now the question is saying, how much is the total accrued from both accounts? So look at the accrued amounts on both accounts. So it means I'm going to get the value of eCapitec ne value yase Nedbank at the end of the period. Okay? So I'm going to add 1238 and 145. So when I add these two, I'm going to get 138427. Okay. Oh, this, ladies and gentlemen, was demonstration of how we think mathematically, especially in your context. You have to work with a real context. Try and have examples. I've thought of Capitec, I thought of Nedbank. You know what, you've got two banks here. Have your timeline and say, okay, something is happening here. Nedbank has got its own rates. As much as you have taken away 1,000 from that amount, there is no way in the story that says the interest rate changes. Things are still the same. The only thing we have done, you've just withdrawn 1,000 yako, uyozifakela yona eCapitec, then you still continue with the same conditions. You are going to have an accumulated amount. Then you got that accumulated amount. Then you calculated your first account, you got the amount, and then you come to eCapitec, you calculate it, and then you combine the accumulated amounts. So what is an emphasis here is how do you decontextualize the context? Make it real. Okay, make it real and feel it. This is money. Nina, you are lucky. You are working with money, something that we all work with. Some of us have to work with discrete math, something that is just abstract. You don't even know. It's just something that is speaking on its own language. So at least, Nina, you are lucky. But the problem is, how do you decontextualize? Train your mind to say, here is the story. As a financial person, what is the story? After you've done that, you must also think like a mathematician. Decontextualize, because you need to start giving us ideas from a financial perspective, and then after that you bring in your mathematician mind, decontextualize it and do your calculations, and then you get your answer. Otherwise, this is how you would go about answering questions like across all of the sections in your module. I'm just giving you the ways of thinking, the discourses, how you break things down, which formulas to bring in at which point. I know it is not easy, but try and think in that manner. Know which discourse. Is it a discourse of compound interest? Which formula are you going to bring in? What information is given by the story? Plug in your mathematics, the critical aspects. What are the common errors? What are the difficulties? What do I want to challenge you on? What are the difficulties that you are experiencing? You can even use this question. This would be a nice question to say, when it comes to compound interest and simple interest, I'm struggling when I've got situation like this. Then you are able to get a one-on-one consultation with me, because you have identify your misconception or your difficulty. Let's sit down and see how we can break things down, so then I can help you to move forward. I am not going to proceed. The reason I'm not proceeding is because I am looking at the time and I don't want to overload you with so many things.
Hi, Dr. Lizaka.
Yebo?
Does your module cover the, I understand that logs have also, I'm like, they also have rules,
Yeah,
just like law of exponents and all that.
yeah.
Do you cover those in your module?
Definitely. There are, it's 1, 2, 3, 4, 5. There are 5 slides that I have not done, whereby you have to look for the time, whereby you said it's a compound interest. So I am going to be pointing you on how to calculate time when it's an exponential form and take you through on the logs, just a little bit on how you can you can use logs. Definitely I will do that. So that's why I'm going to finish off that and do some more exercises on compound interest.
All right. No, thank you
Yeah,
so
I'll
much.
definitely do that. Anything that is mathematically that I think, especially there's another one that I did not do, but I thought there's no really need. There is a slide whereby I was talking about equivalent interest rate with discount rate. That is a formula that is derived from the two formulas. So I thought, it was not really necessary for me to break it down to show you how it's derived. What is important is for you to know what the formula is.
Okay.
Okay, guys. Let us love each other and leave each other. I shall see you when you see me.
Thank you. Bye, guys.
Goodbye, guys.